At this point in the course, you've seen and written both named functions and anonymous functions, but these aren't the only ways of classifying a function. Functions can also be categorized as either pure or impure. So what does that mean to have a pure or impure function? Well, let's consider what a pure function is first. Pure functions are functions that take one or more input parameters, and they return a value that's based on the input parameters and nothing else. So consider this simple add function. Is it a pure function or an impure function? Well, does it have input parameters? Yep, A and B. Does it return a value that's based on the input parameters? Yep, it's simply adding both of the inputs, A and B. This add function is the canonical example of a pure function. There's another way of describing a pure function, which is that pure functions are deterministic, which basically means the function will always return the same value for a given input. So for example, if you pass in a 1 and a 2 to the add function, you'll always get the same answer, 3. It's deterministic. Okay, now take a look at this function, the circumference function. So is this a pure function? Well, does it have one or more input parameters? Yep, it takes the radius as a parameter. Does it return a value that's based on the input parameter? Well, yeah, it does return 2 times pi times the radius. So is it a pure function? In other words, if you pass the number 2 into the circumference function, will you always get the same result? A lot of people would look at this and say, no, this isn't deterministic, because what if pi changes to something like 50? You'd get a different answer, wouldn't you? Let's call circumference again to see if we get a different answer. Well, it gave us the same exact number, which probably surprised a few of you. In many languages, you look at pi and think it's a stateful value, or a value you can change or mutate, but can you mutate anything in Elixir? Nope. You can rebind a variable to a value, but the actual values never change. Here's how you can think about the creation of the circumference function. First, on this line, we create a variable and bind it to the value of 3.14. Now, when we define the circumference function, we're using pi, but don't think of its use in terms of the variable pi. Think of it in terms of the immutable value pi is pointing to when the function is created. Elixir has what could be called proper closures for anonymous functions. Let me explain what I mean. It doesn't matter what you do with the variable pi after the circumference function has been created, because circumference doesn't care about the variable pi. It only cares about the value pi was bound to when the circumference function was created. Another way to think about this is that pi, in the context of the circumference function, is essentially a constant, totally disconnected from this variable pi that can be rebound to other values. So back to the question I asked a few moments ago, is circumference a pure function? Yep. What about this function, Avogadro? Is it a pure function? Well, I would say no, it's not a pure function. And the reason I say this is because I wouldn't consider this to be a function at all. It doesn't take any input parameters. Granted, we're using the anonymous function syntax, but it's effectively just a constant value. Okay, so we've looked at a few pure functions, but what about impure functions? Well, an impure function is a function that involves side effects, which of course begs the question, what's a side effect? A side effect is when a function causes some type of stateful change, or it communicates with something outside of its input parameters and return value. Let me show you some examples. Here's our nice pure add function. But now, for whatever reason, I decided to print out the string adding a plus b. So is this still a pure function? This might seem a bit trivial, but no. It's not technically pure because it's logging something to the terminal, which is changing the state of the console, which is a side effect. Now, I like to break up the general term side effect into two terms, side effects and side causes. Let me give an example of what I mean by side causes. Here's a function named future time. It takes one parameter, hours, and it returns the current time plus however many hours get passed into the function. So is this a pure function? Well, it has an input parameter, hours, and it returns a value based on the input parameter. But is it deterministic? In other words, if I call this function many times with the same input, will I get the same result? Nope. If I call this function 10 times, passing it 1 hour, I'm going to get a different return value every single time. This is another example of an impure function. It's impure because of what I like to think of as a side cause. The side cause being the current time, which is always changing. Essentially, this function is depending on the computer's current time, which is a stateful value. We could refactor the future time function and make it a pure function by eliminating this call to UTC-now and instead adding an additional parameter named time and passing the time into the add function. Now, if we called this function with the time of midnight and we passed in 8 hours, we'd always get a return time of 8 a.m. So is this new pure future time function better than the old one? Or more generally speaking, are pure functions better than impure ones? Yep, they are generally better, and you should write pure functions as much as possible. I'll give you a few reasons why. Think about writing a test for this function. Is it even possible to test the first version, the impure version? Not really. Every time you call it, you'll get a different result. However, the new pure function is easy to test. So writing tests for pure functions is way easier. I'm going to blur out the body of both versions of this function, and for discussion's sake, imagine you don't know how these two functions are implemented. Now, which of these two functions is simpler and easier to understand at a glance? Well, the pure one is fairly easy to make sense out of. It takes a time in hours, and it's named future time, so it would seem logical that it simply adds the hours to the time. How about this impure function? Just looking at the function head, can you tell what it does? It could be adding hours to the current time, or it could be adding hours to midnight, or it could be adding hours to January 1st, 1970. It's really hard to know what this function does without looking at the function implementation. My point here is that it's very easy to reason about pure functions, and these are just trivial examples. Think about how much harder real-world functions can be. What if you had a function that was really expensive, and it took a long time to return a value? Well, if the expensive function is a pure function, you might be able to minimize the costly function calls by using memoization. In other words, you could cache the response to expensive function calls, so subsequent function calls are cheap. Pure functions are parallelizable. To explain this, I'll give you an example that's borderline silly, but it should help explain what I mean. Imagine you've got a list of 100,000 numbers, and you'd like to double each number and save each doubled number to a file. Here's a function you could use to achieve that goal. By the way, this is a horrible function that I'm only using to make a point. Please wipe this from your memory after we're done talking about it. For discussion's sake, let's say we decide to use this function on each number in our list. Okay, so let's walk through this function to understand what would happen. So the file gets passed a number from the list and a file name, and then the file is opened up, and then it writes the double number to the file, and then the file is closed. Now imagine our computer has a whole bunch of CPUs, and we'd like to fully utilize our CPUs to double the numbers, which would mean this function would need to be called in parallel by multiple separate processes. So would this still work? No, this wouldn't work well at all, for a few reasons. First of all, opening a file, writing to it, and closing it 100,000 times would be horrible for performance. But even if the performance wasn't bad, you'd still have another big problem. You'd have multiple parallel processes trying to write to the same file at the same time, and you'd likely corrupt the file. Notice the problem here isn't the doubling part of this function. The problem is the mutating of the shared output file. Now, if you split this function up into a double function, which is a pure function, and you move the impure stuff to a save-to-file function, then you could potentially harness the power of multiple CPUs to double the numbers, and you could avoid parallelism when it would be bad, like writing to the same file. Now, you're probably wondering, how can we parallelize calls to the double function? Hold that thought for now. We'll cover these concepts in upcoming videos. Another big reason why pure functions are nice is because pure functions can be composed together to effectively create new functions by combining other functions. The idea behind function composition is calling one function, then taking the output of that function and feeding it into another function, and potentially feeding the output of that function into another function, and so on. But here's the key thing with function composition. You can only confidently do it with pure functions. A few videos back, when we were learning about passing named functions into other functions, we wrote a simple compose function that combined two functions. But there's a much better way of doing this using Elixir's pipe operator, and that's what we'll look at in the next video.